Right, here's another wee starter. So this involves circles and lines and angles, right? So it's saying RT is tangent to the semicircle at T, okay? Explain why RTC is a right angle, okay? So, well, that's really because if there's a line that's tangent to a circle and if there's a radius meeting that line, it's always going to be right angle. Okay, now if we want to calculate the size of this shaded area, so it's really, we want to be looking at this. Now, if we're willing to accept the fact that this is a right angle, okay, because this would go further down. That's a right angle there, right? Also, we're willing to hopefully accept the fact that there's a chord that intersects at 2 points here. Okay, I'll get another colour. So you'll actually see this wee line here. That's obviously intersecting at 2 points. Therefore, we know that the triangle that it produces is an isosceles. So that side's the same as that side. And that also means that this angle is the same as this angle. Now, we've got 56 degrees here. We know that this is part of a right angle, okay? So we then need to think of, well, what's the other side to actually make up, or the other size that will actually make up this 90 degrees. So it's essentially this angle RTS, that's actually, that's actually equal to 90 minus your 56. And that is equal to 34 degrees. Okay, so that side here is 34. So in order to calculate this one, we're actually still after this side. Now, we know, I'll just draw it here, right? If you've got a straight line, that's 180 degrees. These two angles have to add up to 180 degrees. So what we've got here is we've got 56 and we've got an unknown. Okay, so what we can say here is the angle, so this angle, and we'll call it RST. What that equals to is 180 degrees and minus the 56. And that equals 180 minus 56, 124. And, alright, 124 there. And that is us, because what we can now do, we're trying to calculate RTS, so the angle RT is, it's RTC, I should say. So, sorry, the shaded one, what am I talking about? It's the angle S, so it's angle SRT, right? So it's the angle SRT. That is going to be, because all of the angles in the right angle add up to 180 degrees. So that's actually going to be 180 subtract 124 and subtract 34. So that's get rid of that. That's 180 and that is subtract 124 and that subtracts 180 subtract 124 then subtract 34 and that gives you 22 degrees. So it's really just remembering these rules. First one being if there's a line as a tangent, that means the radius when it meets it is a right angle. And if there is a chord that intersects at 2 points in the circle, then that means if you actually form a triangle, 2 of the sides are the same length, and that means 2 of the angles are the same. And you just need to remember there's 180 degrees in a triangle. Okay, so that angle there, the shaded angle, is 22 degrees. Now there's another question, and it's a similar type of thing, right? So what we've got here is we've got AD as a tangent in the circle centre 0, and DBC is 34 degrees. Okay, so DBC That's 34. So what I'll do here is I might just colour that in. So this wee angle here, that's 34 degrees. Okay, now what we have is we've got a tangent. Okay, so this wee tangent is going to be a right angle there, and that's also going to be a right angle. Okay, so part of this right angle has been taken up by 34 degrees, but we could actually calculate OBC, because OBC is this 90 degrees minus the 34, and that gives you that angle. So if I go angle OBC, what that equals is 90 minus 34, and that equals 56 degrees. Okay, so that's 56. Now we also remember that this is going to be an isosceles triangle because two sides are the radius, because you've got a chord that actually intercepts or intersects at 2 points in a circle. So that's also going to be 56 degrees. And we also know if you have a straight line is 180 degrees. So we've actually got 180 would be from here all the way to here. So to actually calculate the angle BCD, so angle BCD, that's actually going to be 180 subtract 56. I'll just get that calculator. 180 subtract 56, and that gives you again 124. So I think it's the same values as the last question. So this is 124. So the angle that we're looking for, therefore, angle CDB, that equals 180 minus 124 minus 34, and it's the exact same as the last one, 22 degrees. Just to double check, 180 minus 124 minus 34, yep, that's 22 degrees. Okay, so again, you just break the problem into the three areas. Perpendicular, so it's a tangent, so therefore it is going to be a right angle. If the triangle's got two radius, as two of the sides are equal, therefore these two angles are equal, and we've got 180 degrees in a straight line. And that's the answer to these two questions.